Hello and welcome. In this video, we continue our journey through different measures of variation. Again, we consider a quantitative variable x, and suppose that we have collected data on this variable x from an underlying population, and we have listed the data being collected as x1, x2, x3, and up to xn, where capital N is representing the population size. Then the fourth measure of variation that we use in order to check the amount of variation in our data set is variance. Variance 2 tries to measure the distance of each observation from the center. The formula for the variance is 1 over n, the sum of xi minus mu all square. If you recall the mean absolute deviation, the difference between variance and mean absolute deviation is that in mean absolute deviation here we have xi minus mu absolute value, but here we have in variance we have xi minus mu all square. For example, consider again the example of age of all 9 employees of a company where the mean was 29. And then we use this table where we have listed observations here in this column. And then in this column, we subtract the mean from each observation, find the difference. And in the last column, we square it. 22 minus 29 is minus 7. Minus 7 squared is 49. 37 minus 29 is 8. 8 squared is 64. The same is applied to all other observations. And in the next step, obviously, we find the sum of xi minus 29 all squared. That's the sum of all numbers in this column, which becomes 220. And in the last step, we divide the sum by n, by capital N, which is the population size here, which is 9. 22 divided by 9 is 24.4. In fact, this 24.4 is kind of representing the distance of observations from the center, which is the mean here. But there is a fundamental problem that the variance has, and that is that the unit for the variance is not standard. The reason being that as you square the difference, you square also the unit. That is minus 7 years squared is 49 years squared. 8 years squared is 64 years squared. The same is applied to all other observations. And as you sum up, here we get 22 years squared. And dividing 22 years squared by 9, you get 24.4 years squared. And we know that years squared is not in a standard unit for age, because the standard unit for age is only year, not year squared. Therefore, in order to get rid of this problem, we introduced another measure of variation, which is called the standard deviation. Standard deviation is nothing but the square root of the variance. The standard deviation of the variable x, which is shown by the sigma x, is equal to the positive square root of the variance. For instance, the standard deviation of the age is equal to the positive square root of the variance of x, which is the positive square root of 24.4 years squared, which is 4.9 years, because that square of the year is being cancelled out with this square root, and what we are left off is 4.9 years. If you recall, the value of mean absolute deviation was very close to this number. In fact, the two are giving us the same idea. That is, the distance of each observation from the mean is 4.9 years on average. This 4.9 years means that the distance of each observation from the mean is on average 4.9 years. The last measure of variation is coefficient of variation. In fact, coefficient of variation indicates the size of standard deviation in relation to the mean. In particular, coefficient of variation is used to compare the variation of two or more variables with different units. Why that's the case? The reason is that coefficient of variation, or CV, is a unitless measure of variation, which is being calculated by dividing standard deviation by mean. And you know that this unit with this unit, they cancel out one another. As a result, CV is a unitless number. And this unitless number is helpful when we compare the variation of two or more variables with different units. As you can see here, this is the ratio of standard deviation against the mean. If this ratio is equal to 1, that means the standard deviation is equal to mean, which is not happening a lot. If this ratio is less than 1, that means standard deviation is smaller than the mean. Usually the people show the value of coefficient of variation in terms of percent, which shows that how many percent of mean is the standard deviation. Going back to the example of the age again, we have the standard deviation of age, we have the mean of the age, that's 4.9 divided by 29, which is 0.17. If we convert this to percentage, this is 17%, meaning that the standard deviation, that means the average distance of every observation from the mean, is 17% in terms of the value of the mean itself. Thanks for watching and good learning.